Welcome to this online video lecture. This is Dinesh, Assistant Professor in EC Department, Government College of Engineering, Tanjavur. The subject is Communication Networks. We are in Unit 2, Media Access and Internetworking. Today's topic is Media Access Control. So these are the concepts we are going to cover today. We start with Introduction to MAC, and we're going to see the classification of multiple access protocols, like random access protocol, controlled access, channelizations, and the types. First of all, what is called MAC? So media access control, otherwise medium access control. So we discuss about data link layer. This is part of data link layer. We talked about data link control, the previous session, about line discipline, about flow control, error control, framing, addressing. So these things we discussed in the previous session. So this particular part about MAC, they're talking about channel, the transmission medium, the communication channel. So how to access the channel, who to access, when to access, and how to avoid the collisions. So we already talked about point-to-point communications. See, there we discuss about reliability and efficient of data transfer. And we can do that with the help of some protocols as we discussed in the last class. Now we're going to check out about the MAC layering. And for example, if you talk about unicast or broadcast, multicast. So unicast is about one-to-one, in other words, point-to-point. But about broadcast is about one-to-many, point to multi-point, and multicast about many-to-many. So this particular MAC, the media access control, is suitable for broadcasting communication as well as multicasting communications. See, if you talk about how to select the or access the channel and what are the techniques we have, so how to utilize that and how to avoid the collision. See, the set of functions to support the sharing of single link by a multiple endpoints. So that part, it is about MAC. So we are going to deal with internetworking, and we do talk about network topology and how to debugging a node. So the debugging a node is not easy when you talk about multiple nodes are communicating, and so how to giving a priority or how to give a authorized or authorization to the node. So these things we have to consider. See, normally the protocol that determines how nodes share the channel. So that we are going to see in media access control, and when the node can transmit. And we do talk about channel sharing. So there is a comparison about MAC versus multiplexing. The term MAC is used to describe sharing techniques on multi-access links, multi-node links, like broadcasting communications. Whereas the term multiplexing is used to describe sharing techniques on point-to-point links. See, in most networks, the multiple nodes share a communication medium for transmitting their data packets. And the medium access control protocol is used to regulate that communication between that, regulate that sharing medium. If you talk about internet, so that is about sharing the bandwidth, how we are sharing the bandwidth without interference, without collision, how it is possible. So that techniques we are going to check out today video session. So the choice of MAC protocol has a direct bearing on the reliability and efficiency of network transmission. So as we discuss about point to point, We get a reliability and data transfer in data link control. Some of the protocols like stop and wait protocol and acknowledgement protocols. So flow control methods, mechanism. We've seen a lot of things about one-to-one communication, whereas point to multi-point communication, so we need some reliability through this type of techniques like random access, controlled access protocol techniques. See, many protocols have been devised to handle access as shared link. All of these protocols belong to sub-layer in a data link, sub-layer in the data link layer called media access control. So we are in the communication network about we are going to learn about that OSI model, how that data, packet, frame, and where it will be encapsulating, where it will be decapsulating. In this particular part, the MAC will be the sub-layer of data link layers that they are discussed in this particular session. So as I said earlier, the multiple access protocols have three types or three classifications. Starts with random access protocol. They have a pure Aloha, slotted Aloha, a CSMA, carrier sense multiple access. And they have two methods. One is for collision detection and collision avoidance as methods used in random access protocol. So next one is controlled access protocol. They have three categories: reservations and polling and token passing. And about channelization protocols, well-known things like FDMA, frequency division multiplexing, multiple accessing, and TDMA and CDMA, time division and code division multiple access. We start with random access protocols. So if you talk about random access protocols, so there is no scheduling for transmit that packet or transmit the data from one node to another node. The transmission is random among the stations. That's why it is named as random access. And there is no rules will be followed one node to another node. And one more thing, there is no control will happen. I mean, no other station will control another node. And they have a issue in collision interference is possible. If it is a collision will happen and we need to destroy the packet or a frame or modify. And if you want to avoid collision, we need to follow some procedure. Say in random access or contention methods, no station is superior to another station. So there is no control between the nodes. If you talk about Aloha protocol, see the Aloha protocol, and not only Aloha, we start with Aloha and we end with CSMA. So they have a techniques like collision avoidance and collision detection in that CSMA. Whereas in Aloha, we send a frame. We send a frame and we get acknowledgement. If you never get acknowledgement, we will resend the frame. So this is the basic thing about Aloha protocol. See, it uses acknowledgement to confirm the success of broadcast data transmission. So once you get the acknowledgement, there is no need to send the frame again. Allows nodes to access the medium immediately. There is no protocol, there is no rules to stop the nodes to sending a data. And addresses the collisions. We can address collision, but we never give a solution to collision in Aloha protocol. Whereas we can either destroy or modify. So the addresses the collision with the approaches such as exponential backoff to increase the likelihood of successful transmissions. This is an example of, as I said, Aloha have two classification. One will be pure Aloha and another will be slotted Aloha. In that pure Aloha, each station can send the frame. But the problem in that, if you send a frame, if you check out station 1 is sending a frame, at the same time, station 2, station 3, station 4 are not sending any frames in this particular period. But when you take overall a picture of this particular pure Aloha, we have 8 frames are sending if you count that frames will be present in the station 1 up to station 4, there are 8 frames of sending. So in that 8 frames, some of the frames, if we check out here, we have the station 1 as well as some of the bits will station 2 will be collide to station 1, and station 3 as well as station 2 will be collide as well as station 4. So this particular part is a collide and collision will happen. So the collision duration will be there. So totally we have 8 frames. In that some of the frames will be collide because of the frames, the bit will be accessing the channel at the same time. In slotted Alaga, it's about increase the efficiency of pure Alaga. So if you talk about starter Alaga, it requires that station. It deals with a time slot. It will give a intervals, time intervals. It fixes the time to each station and sending the frame according to the time slot. They have some procedures to follow the sending a transmission in one end to another end. So it requires that station may commence transmission only at predefined points in a time. As I said, the beginning of time slot. This will cause increase in the efficiency of Aloga. Introduce the need for synchronization among nodes. Whereas in pure Aloga, we never care about other nodes or other station. We never talk about coordination, but this particular Aloga will talks about synchronization. The coordination part of other nodes too. The slotted Aloga divides the time of shared channel into discrete intervals called time slot. So this slotted Aloga will run through time slot basis. See, if you take this example, so again, this particular diagram about sending a frame. If all the stations are sending the frame, if the frames are sending different time slots, or if both the stations are starting the frame in the beginning of time slot. If we talk about station 2 and station 3, are both get collide if you check out. But whereas if you talk about station 1 sending a frame in one particular time slot, whereas station 4 sending a frame in a slot 3. They are sending slot 1, they are sending slot 3. So for example, if the station 1 missing the slot 1, then he can't, this particular station will never send a frame in a slot 2. It's not possible. The station 1 needs to wait for the slot. So that's the thing here. But it is also possible to get a collide, but we have some synchronization, but the station 2 and station 3 will still have a collision because of they have started data transmission or a frame transmission with the same time slots. That is the issue in slotted Aloga. Then we move on to CSMA. If you talk about CSMA, carrier sends multiple access. In 2 words, we can summarize it. That CSMA, sense before medium or listen before talk. So that is the rule we have to follow in CSMA. And one more thing, it reduces the chances of collision compared to pure Aloga as well as slotted Aloga. It reduces the chances of collision, and it works on principle sense before send. Advantages is simple to implement and the functional schemes that works. It can't eliminate the collision permanently. That is the issue here. So as we discussed, the carrier sense. So in the sense, is anyone transmitting a data? The carrier sense means we are going to check out other nodes. I'm going to sense the channel, sense the medium, the common link. I'm going to check out the common link, whether any other nodes are sending a package or a frame or a bit. So that I have to check first. Then if the channels are, if the stations are ideal, my neighbor stations are ideal, then only I can send a packet or send a frame to the channel. If the stations, my neighbor stations or some other stations are getting busy, then I have to wait for some time to send the packet. So after they are completing that transmission, then they come to the ideal stage, then only I can proceed for my communication. So that is the thing here. Now we discuss, still now we discuss about that multiple accessing, about multiple node or multiple computers, how they are connecting. So the Mac is suitable for multiple access. So that's the dealing about here. The collision detect, if you have A and B and C computers, A can communicate with the C or A can communicate with the B. So for example, if A starts sensing about the neighbor station, but sometimes the C's computer may have started sensing in the medium. So that get collide. So that issues are available. We'll see in the example. And about there are two methods. One will be carrier sense multiple access collision detection. So the same thing. The sender first sends the medium and to determine whether it is ideal or busy. As I said, if it's found busy, the sender refrains from transmitting packets. If the medium is idle, the sender can initiate the data transmission. If collision occur, then stop and talk after back of time. So this is an example I said. If you talk about A, B, C, D, or 4 stations are available, when the first A needs to send the data transmission, it starts with the first bit of A for sensing that medium, whether any transmission happening here. I mean, any channel transmission. I mean, any other, for example, B, C, D are the stations, or whether they are accessing a channel or they are accessing a medium. So that will be done through sending a bit to check the channel is busy or idle. If you check out this diagram, A started for first bit from A station, and it identifies that C is also trying to sense that medium, and they are going to sending a frame. But the problem is A doesn't know when they are starting a transmission, because the neighbor station B is not at all sending any data or sensing. But whereas C started sensing about the transmission about that range of T2, whereas this collision will happen in that particular time T4. Once the reaching, that medium C is also reaching and A bit is also, that kind of collision will happen here. So if it is a collision will happen, they both will be destroyed, and again they need to resend the frame, and it needs to wait for some period of time. So CSMA with collision avoidance, how to avoid that collisions, that we have an issue like the third station or fourth station started sensing or started sending frames. We don't know about when we are starting a transmission, but our neighbor is not sending a data. So if you talk about CSMA, CA, it was invented for wireless networks, and it avoid from collision. It uses 3 stages to avoid from collision. Starts with IFS, interframe space, the contention window, acknowledgement, and it is request. It is using RTS and CTS. I mean, request to send and clear to send. So they set a time period and they form a temporary memory and managing the frames, and they are getting acknowledgement, and after getting acknowledgement, they are sending the data. They request to send and clear to send. The sender and receiver are both to be coordinate and synchronized. Then they will doing communications. So that type of things is there in CSMA with the collision avoidance. Once we see the collision, we fix interframe space, they set a time period, then we come back and sending a data and sending a frame, and we have a contention window, and we're getting acknowledgement from the receiver side. If it is a positive acknowledgement, we will proceed with that transmission channel, and if it is a negative acknowledgement, we have to resend the frame. And we do have a like handshaking procedure. We are giving request as well as getting a signal from, we are giving RTS and they are giving CTS, and then they will proceed the transmission. So next part is about the controlled access. The controlled access, in one word, it gives, I mean, another set of techniques about multiple access or multi-node communication, common accessing of channel, the common channel, how to access the common channel. This is about authorization. This particular control access protocol giving authorization to the stations, how they are doing. So this is otherwise called as dynamic assignment strategy. It allows nodes to access the medium on demand. In control access, the station consult one another to find which station has right to send. They're given a right. A station cannot send unless it has been authorized by the other stations. So this is dependability will be coming in this picture. For example, we start about other techniques we have. I mean, control access. There you learn about that. Polling based protocols. So the polling based protocols, they have dependability like primary station and secondary station. So they have a select frame. So once that the node transmission happens, if you want to reach the destination, we will go through on primary station, then we will reach the secondary station. So that is the polling based protocol. A controller device issues small polling frames in round robin fashion, asking each station if it is data to send. So the each station has to, the authority will be, the controller will be there, is asking about polling about all the station. If someone needs to send the data, so if the no data to be sent, the controller polls the next station. So if you want to send the data, the controller will give a chance. So that is a way of primary station to secondary station. Token passing. The token passing, some of the great examples, they're using token passing like fiber distributed data interface are using token passing, like copper distributed data interface are the examples of token passing. The token passing, station pass a polling request to each other as like a round robin using special frame called token. If you have the token, you can start proceeding with the data transmission. So you wait for your turn. Then if you got a token, you will proceed with the data transmission. That type of thing is called token passing. The station is allowed to transmit data only when it holds the token, as I said. Reservation-based protocol, another one of the classification in controlled access protocol. This is, they have a fixed time slot are given to the user. The static time slot are used to reserve future, where you can reserve it, future access to the medium. Example, a node can indicate its desire to transmit the data by toggling a reservation bit in a fixed location. It's possible there. It is often very complex protocol that ensures the other potentiality and conflicting nodes like collisions. They take a note of such a reservation to avoid collisions. So the last one is channelization protocols. So the partition of channel and dividing the resource. So this is one of the technique about multiple accessing. So this is also called channel partition. Is also called multiple access method, in which the available bandwidth of a link is shared in a time, in a time manner or a frequency manner or through codes among different stations. So we are going to discuss three channelized protocols, the famous protocols like FDMA, frequency division multiple access, and time division multiple access, and code division multiple access. So if you talk about FDMA as well as TDMA, they have a dedicated channel will be available. They divide through, if you talk about FDMA, they divide through frequency. I mean, they have a separate frequency band for each stations or each node will be given. The frequency band is divided into several smaller frequency bands. The data transfer between pair of nodes use one frequency band. This one of the thing is about the sender and the receiver is allocate the resource in FDMA. So that is one of the things. Both will coordinate and sending the frequency. And one of the things is a dedicated channel. This is a good thing, as well as it is a drawback because if the frequency band is not at all used because we are given this particular frequency is given to the default station. that may is ideal in some mean period of time. So the sender receiver coordination is not good when you talk about overall multiple link, multiple node. I mean, several nodes we need to pass over, and so that type of communication we need to concentrate more on sender and receiver sides too. A TDMA is both the time division multiple access through time slots. They give a time slot. Each station you have some particular time period is given. Through the time period only we can send the data that is dedicated. That is this particular station is dedicated for a particular user. So then if the user is not used the channel, that will be wasted one. So that is ideal. If it is ideal, that is very wasted. When I have a low, I mean, if you have a high number of users are using that, that will be advantage. If it is, if the user is not at all using that particular time period, then it have a problem. And one more thing, this is the resource will be allocated in only in the sender side, not in the receiver side. That is also in available in TDMA. So whereas if you talk about FDMA, they have both multiple devices to use the same frequency band and relies on periodic time, I mean windows, the frames. The frame consists of fixed number of transmission slots to separate the medium access of different devices. The time schedule indicates which node may transmit to data during a setting slot. Find what is CDMA. I mean, this is about code division, multiple access. We use some code for identify the users. The simultaneous access of wireless medium are supported using different codes. If these codes are orthogonal, it is possible for multiple and communication to share the same frequency band. And we do use the word forward error correction at the receiver. It's used to record from the interference among the simultaneous communication happening in a CDMA. So that's all about this particular video session. I mean, we talked about how to access the channel, I mean the common channel, and we discussed about 3 set of protocols. I mean the multiple access techniques, multiple access protocols like random access, control access, and channelization. So this particular access, media access control, some of the things are most used in wireless as well as wired. Some of them will be used only in wireless, and it will adapt both mediums, wireless as well as wired communication. So as we discussed, and we have set of classification for random access as well as control access, and about channelization. So these things are present in data link layer, the sub layer. The MAC will control this particular part of who to access, how to avoid collision, how to set the frame, how to send a bit, and this how to avoid the collision, how to give the channel to access the transmission medium without any interference. So giving a reliability and efficient communication for broadcast communication as like multitask, I mean multi-point communication. So it's very much useful. Thank you.